The Earth revolves around the Sun, rotates on its axis, and the Moon revolves around the Earth. Now, this has been a basic information that has been given to us right from our childhood, and this will be the fundamental basis of our class today. That this simple interaction between three planetary bodies, the Sun, the Moon, and the Earth, have had a direct bearing on the length of the day on planet Earth. Hello and welcome to StudyIQ IAS English. My name is Bhuvan Apurvajha. As in this presentation, we will take a quick look at the factors behind the length of the day on Earth, what formed and what caused the change. Because when you study Earth's history, you realize that the length of the day has not been uniform. That earlier, the length of the day was shorter, and now it is longer. And guess what? It could have been a lot longer. In fact, one day could have been as close to 60 hours, if not for this interplay between the Sun, the Moon, and the Earth. Alright, so this is the focus of our discussion today. Let me welcome everyone once again. Hi Arka, Deepak, Bulbul, good morning. Guys, welcome everyone. Alright, so we will straight away jump into the discussion. So like I told you first, that the length of the day on the Earth has not been uniform. In fact, when the Earth was formed close to 4.5 billion years ago, what you find is that the length of the day on the Earth would be close to around 3 hours. Only 3 hours. Alright. And that the Moon would go around the Earth, complete one orbit around the Earth in around close to 5 hours. So what caused this change now? Why is it that suddenly we have one day equals to 24 hours and not say 3 to 4 hours what was happening initially? Well, a lot of factors at play here. Good morning Tanu. Welcome. Welcome guys. Alright. So we'll take a look at that. The length of the day has varied, like I told you, since the Earth was formed, and that there was a billion-year pause in the slowing of a planet's rotation. So once you have to realize now that the planet's rotation is eventually slowing down, and that eventually a day shall come when the Earth would stop rotating. Alright, but then that day is so far in the future, but that by the time the Sun that we know it of as now would probably become a red giant, a supergiant. However, first understand that an atmospheric tide driven by the Sun countered the effect of the Moon, keeping Earth's rotation rate steady and the length of the day at constantly 19.5 hours. That this interaction between the Sun's gravitational field, the Moon's gravitational field, and Earth, now this is directly correlated to the length of the day on the Earth. So without this pause that I'm talking about, that we will understand in a few seconds from now as to what happened, why was this pause? Why is it that the Moon suddenly stopped affecting the Earth's rotation? Why is it that the Earth's rotational velocity also remained constant? Alright, if this pause wouldn't have happened, like I told you, one day would have been equal to 60 hours, imagine that. Alright, so first if you just go through in the history of the Earth, what you find is that again, like I told you, our length of the day has not been uniform. In fact, it has been increasing. And so during the dinosaurs, the Mesozoic era, you find that the length of the day was close to 23 hours. Right now, it is close to 24 hours and increasing. And so why is that happening, right? Why is it that the Moon is also going away from the Earth? So if you look at this particular figure here, what you find is that the Earth is not just slowing down. You also find that the distance between the Earth and the Moon is now increasing. Why is that happening? We will discuss and understand that very quickly. So, when the Moon was first formed, the day was less than 10 hours long. Now, since then, the lunar gravitational pull on the Earth has been slowing our planet's rotation, resulting in an increasingly longer day. Please understand it as this, that because the Moon has its own gravitational field, the Earth has its own gravitational field, both are revolving, rotating in fact. What happens is that because of this interaction, you find that the Earth is giving some part of its energy to the Moon in the form of angular momentum. Okay, this is a term that you have to understand, that the angular momentum transfer from Earth to Moon is in fact contributing in this growing distance. And so for a very brief example, if you have to understand this, if you're at the park with your brother or your sister, and if they are on that go around, and if you are pushing them, suddenly if you want to stop them, you will find that you will be carried forward with the force, with the momentum that they are coming to you. That is essentially what is happening here. Because of the transfer of angular momentum, you find that the moon is slowly drifting apart, away from the earth, right? So today, because of this, what you find is that it is continuing to lengthen the rate at a rate of 1.7 milliseconds every century. Because of this increasing distance between the earth and the moon, well, the length of the day is increasing on planet earth, right? So obviously, you're looking at these two forces that I just told you about as to how moon affects earth's rotation. You're looking at the interaction of the gravitational forces and also the transfer of angular momentum, which causes this increasing distance. Let's go forward and now look at this. The moon slows the planet's rotation by pulling on the earth's oceans. You must have read in the NCERTs about the tidal bulges. What causes tides? The neap tide, the spring tide, the rip tide, different types of tides. Now, without going into the details, what's for you to understand here is that because of this tide formation that is happening, the weight of the planet, the mass distribution within the planet is getting affected. Now that affects the moment of inertia, which is a major proponent of any rotational dynamics. Because the weight in the Earth's surface is not uniformly distributed, it is getting shifted around due to the moon's gravitational action, you find that the Earth's rotational speed is getting slower, right? So these create tidal bulges on opposite sides of the planet that we experience as high tide and low tide. So this is it. You're looking at the Earth here, the moon here, the gravitational interaction between them causing the tidal bulges on both the sides, which affects the moment of inertia. So the gravitational pull of the moon on those bulges plus the friction between the tides and the ocean floor, well, that affects and acts like a brake on the rotational velocity of Earth. So tidal bulges stretches at the equator, flattens near the poles, and this causes change in the water distribution on Earth, which is why you suddenly find that, well, the Earth is coming to a halt, slowly but steadily, right? So it is not just the moon again, guys. We'd be wrong in thinking that it is just the moon that is causing this. Well, of course, like I told you, three stakeholders in this conversation: the Earth, the Sun and the Moon. And so now we will seek to understand as to how the Sun is affecting Earth's rotation and how exactly that balance happened. Why is it that for a considerable point of time in Earth's history, a day was stuck at 19.5 hours when we began from 10 hours length of the day and now we have reached 24 hours? How did that happen? Obviously, the effects of the Sun, the Moon and the Earth, all three need to be individually studied. So let's look at the Sun's contribution now. The sunlight also produces an atmospheric tide. In fact, what you find is that sunlight has a direct bearing on the atmosphere. There is a lot of friction. It stretches the atmosphere in different ways, which is why you find that atmospheric bulge is also created, much like the tidal bulge, that the atmosphere also stretches and pulls and pushes in different directions. So the Sun's gravity pulls on these atmospheric bulges, it produces a torque, and because of the torque, what you find is that it speeds up the Earth's rotation. So there you have it, the Moon slowing Earth down, the Sun speeding Earth up. Eventually, a balance was achieved, which made sure that today the Earth's rotational dynamics is considered and that our length of the day is at 24 hours. Okay. So for most of the Earth's geological history, the lunar tides have overpowered the solar tides by a factor of 10. Okay. So you are looking at both these actions, but the lunar one is obviously much more powerful because it's in the proximity. So around 2 billion years ago, the atmospheric bulges were larger because the atmosphere was warmer, and now we come again to a new concept of resonance, the resonance of the atmosphere. Okay. For the exam perspective, I suggest making a note of this. Obviously, this whole slide will be available on my Telegram channel. But for the basis of our understanding, please understand resonance now. How does atmospheric resonance help our understanding? Well, let's go forward. We'll come back to this slide. So please understand, the atmosphere, like a bell, resonates at a frequency determined by various factors, primarily temperature. So if you have in fact observed, at similar temperatures, a bell will always produce the same note. The same concept is extrapolated in terms of the atmosphere also. That at a constant temperature, it will behave in a similar manner, right? Waves travel through it at a velocity determined by its temperature. So throughout most of the Earth's history, atmospheric resonance has been not equal to our rotational rate. Because of this divergence, everything was fine. However, what happened was that each of the two atmospheric high tides, well, they take around 23 hours. Today, it's around 24 hours. But during the billion-year period of study that we are discussing, what you find is that the atmosphere was warmer and it resonated with the period of about 10 hours, the same as that of Earth's rotational speed. So a balance was achieved, like I told you, between the sun's action and the moon's action. Because of this balance, the length of the day was stagnant for close to 1 billion years. What you also find is that because the length of the day was stagnant, that today, because of that pause in that increase of the length of the day, today we are at 24 hours per day. Had that pause not happened, you would have looked at 60-hour per day work schedule, right? So let's go forward. You find that at the advent of the epoch, Earth's rotation slowed down by the moon reached 20 hours, and then this is the operative word. The atmospheric resonance and then the length of the day became even factors, and thus the sun's tidal pull became stronger enough to counter the lunar tide. Finally, you had a situation where the sun's gravitational field and action was almost as visible and as important as the lunar action. And thus, this balance that we are seeking to achieve was achieved. In fact, if you just understand it in a very basic sense, what happens? When this boy is at its highest position here, if you are pushing this boy from a high position here, when he is right at this position, the force with which you push is going to be higher. But that timing needs to be proper. That is resonance. However, if you were to push when the boy is still here, well, he is not going to go farther up. He will just remain here. So that is the angle that is being extrapolated here. The timing was such that Earth, the Sun, the Moon all came together to balance the length of the day on planet Earth. And so what are the other factors that are to be understood from the examination point of view? Well, you are looking at earthquakes. Once again, anything that redistributes mass on the Earth will affect the moment of inertia of Earth. So you're looking at major catastrophic events, right? Climate change, the melting of ice and increasing seawater, the volume of water, once again affecting the weight distribution of water on the Earth. You're looking at events such as massive earthquakes, movements of molten core, all of this within the Earth affecting the weight distribution of the material inside plus the material on the surface of it. Which is why from the examination perspective now, the tangible outcomes for you, the outcome based learning that we always focus on here, well, you can go ahead and answer the question for me. Which of the following affect Earth's rotational speed? Right, we have discussed the theory, the basics of it. So let me know, does the movement of molten core affect the Earth's rotational speed? Does the gravitational action by moon affect Earth's rotational speed? Does the movement of ocean water, bulging of atmosphere and climate change? Let me know your answers in the comment box. We have discussed the theory for it. We have discussed the various factors that affect Earth's rotational speed, as well as we have understood why the moon is going away from Earth. We have also understood how the moon is now slowing down the rotational velocity of Earth, All of that put together is the crux of this article that appeared in Science magazine, which essentially said that because of the dynamics at play between the sun, the moon and the earth, and because of the balance achieved between the sun's gravitational field and the moon's gravitational field, you are at a stage where the length of the day on the earth is 24 hours. Had that not happened, you were looking at a scenario wherein the length of the day on the earth would have been close to 60 hours. Alright? Thank you, Bulbul. That's absolutely correct. So with that, my dear friends, I'm happy to note your answers. In fact, I would suggest that you go ahead and read up more about this in the NCRTs. A very important topic that is now in the news, and so it will be best advised that any serious student of UPSC Civil Services 2024 makes himself or herself aware of this. On that note, this short this short video comes to an end. I hope it was informative for you. If you enjoyed learning about the sun's action, the moon's action on planet Earth, well, go ahead and leave me a like, and I'll expect to see your answers in the comment box below. On that note, have a wonderful day, and I shall see you again soon.